Okay, now that we've done some confidence intervals and hypothesis tests comparing two proportions, let's just expand that idea and do confidence intervals and proportion or hypothesis tests comparing two means. And there's actually two different ways that we're going to approach this. So we're going to look first at means that are independent of each other, where the data sets are just two different groups that are independent. In the next section, we'll look at something where they're not independent. But for the moment, just independent means. So let's say that I have a hypothesis that I want to test, that during the quarantine, people's pulse rates are higher. So I'll make a claim. And maybe not people. Let's go SVC students. So my claim is that SVC students have a higher average pulse rate. During this stressful lockdown time. Hopefully by the time you're watching this, some of that lockdown will have been eased, but we will see. Okay, so let's set up some hypotheses. We're going to say quarantine and non-quarantine. And the claim was that the average, the mean, during quarantine is higher or bigger than the average during non-quarantine. The opposite claim, of course, would be that the average during quarantine is less than or equal to the average during non-quarantine times. Well, this is where you would go and gather some data, and it just so happens that I have some data. So I've been asking my stats classes to give me their pulse rates for a long time, so I grabbed your pulse rates and also some from a class back in 2013 that I did. So there's just a little bit of the lists there, but the more important part for us is the summary statistics in that little table. And it does seem like in the sample, the mean now during quarantine is 77. And the mean during non-quarantine times is more like 70. So it is higher now, at least in this sample. Of course, samples do vary. And we want to say, aside from sample variation, is there really statistical proof or at least strong evidence here? So this is where we need StatDisk. So go ahead and grab StatDisk. And we want to go to analysis. We want to do hypothesis testing. Let's keep in mind that will generate the interval also. And we want to do means, two independent samples. Okay. So we are going to use the summary statistics because we have those right here. You could, if you just had raw data, like if you just had these lists here, nothing else, you could click use data. Anyway, we need to start with our alternative hypothesis, which for us is that mean one. Oh, I didn't label alternative and null, but you should know those by now. I'll label them in a minute. We know that mean one greater than mean two is our alternative. So population mean one greater than population mean two. Significance level was not specified, so we use the default of 5%. And then go ahead and put in our samples. Sample one, the way I labeled things was the quarantine, the 2020. So sample 1 had a size of 38. And the mean for sample 1 was 77.3. And the standard deviation for you guys was 12.9. Don't know the population, standard deviation. Okay, for sample 2, for my class back in 2013, that was, there's actually 2 classes put together. It's 47 students, and their average was a 69.7, and their standard deviation was 13.2. And the population standard deviation was not known there either. Notice there's a new question down here. It says, hey, unequal variances or equal variances, or do an F-test to check if variances are equal. We are basically just going to stay out of the pool here. We're always going to pick no pool. And it even says recommended right here. But if somehow you knew that these 2 populations had the same variance, you could improve your test statistic just a little bit by doing equal variances, but we don't know that. And it would be weird to know if the variances are the same, especially since we don't know if the means are even the same, right? That's what we're checking. So how are you going to know variances if you don't know means? Anyway, all that to say, stay out of the pool. No pool. Every single time. Okay, go ahead and evaluate. The important bit for us is the p-value, which is 0.00456. And I should go ahead and label this one as the null. This one's the alternative. Based on this p-value, our sample is unusual. And keep in mind that's based on if the null is true, our sample's unusual. So we are instead going to say, I don't buy the null. We're going to reject the null. So say I don't think it's true that quarantine pulse rates are less than or equal to non-quarantine pulse rates. What I think is true instead is that quarantine pulse rates are indeed higher than non-quarantine pulse rates. So writing your sentence, you would just say there is evidence that, and I'm going to cheat a little bit right here, and we're basically just going to write that exact stuff, right? There is evidence that SVC students have a higher average pulse rate during quarantine, during lockdown, than they do during other times. Okay, so the homework is always going to ask you to do a hypothesis test. They're always going to ask you to write a confidence interval as well. So let's go back to StatDisk. And the confidence interval is right there. It was about 2.9 to 12.3. And again, if you're going to interpret this confidence interval, keep in mind it always talks about how much bigger group 1 is. Group 1 is than group 2. So you could say average quarantine pulse rates are anywhere from 2.9 to 12.3 beats per minute higher. And you could say higher than non-quarantine pulse rates. I think that's pretty well understood here. I might just put a period and just say average quarantine pulse rates are anywhere from basically 3 to 12 beats per minute higher than they would be during non-quarantine. Okay, so that's the basic idea. I do want to do one homework problem, so I'll do that in the next video, and then you'll be ready to tackle the homework.